So what is Python? To start, we're dealing with an object-oriented language. What that means is the individual things that we create and are dealing with within this language are objects and have methods. This means things that we can do specifically with that type of data. We're personally going to be using Python for web applications like interacting with Cisco appliances, servers, switches, etc. But we can also use this for app development. So I personally have developed a few automated text programs, some data visualization, really whatever you can think of. So one of the huge benefits of this language, and don't hate me later when you're working on this and you say, well, it's not as easy as taking a walk down the street, but compared to other programming languages, Python is relatively easy to learn. And the reason that's the case is because it's a fairly simple language with regard to what we're typing, what we're doing inside the code. We don't have a whole bunch of setup that we need to worry about. Like in Java, if you want to write a simple hello world script where just the words hello world are outputted to the terminal, it's like 9 to 10 lines of code just to set it up and declare that this is a public class and this and that. With Python, that's one line. We print hello world, right? It's very simple. So there are a lot of nice little simplifications like that within this language. And in addition to that, the high readability, meaning I could read this, some lines of code in this language I could actually read as a sentence even. So that makes this language a lot easier to learn and work with. As opposed to programming languages like Java, which are compiled, and then we're creating a new file type, a compiled Java file, and then executing that file, that new thing we've created. Python is a scripting language. So it's going to be interpreted as opposed to executed, or compiled and then executed. What does that mean? It means that the code that we type is what we're going to run, right? Simple as that. Instead of having to have this other step in the middle where we compile it first and then execute that compiled file. And we see here we have slower processing time, but a lot more functionality and readability. And so the things we're typing, right, the Python code that we're typing is still being converted into bytecode and executed on the machine. But this makes it, obviously, it's a lot easier to type something like this than a bunch of ones and zeros. So for us, that's a win. Supported by many platforms, meaning Python has the ability to deal with a huge variety of different tasks, right? Whatever computing task you have. And the reason this is the case is because Python is modular. So there is a collection of libraries or code that was already written by some team or organization that we can use, right? It's all open source, so we can just say, okay, well, today I want to SSH to something. So we're going to go find the appropriate collection of code that's going to enable us to SSH or write a PlayStation game or create a data frame that's going to be interpreted by some web server that's going to display the data. There are a lot of options. So the first thing you're going to look at when we're dealing with Python is the syntax, right? The basic operators and organization of the code by itself. And then once you have a good understanding of the syntax of this language and the grammar, then we'll start looking at different libraries that would enable us to do these different specific tasks and deal with these different platforms. So we have also procedural programming and object-oriented programming. So procedural programming is when you take one task and you break it down into variables and functions and sub-processes, is the same thing, functions, sub-processes. But we're breaking down this overall task into smaller segments of code that we can essentially create a flow, right? we're going through the script in a specific order that's called the flow. At some point, you'll encounter control flow tools, which are going to enable us to change the order that the script is running. Right? So it's like if I create a variable, x equals something, well, now that I have that, instead of just interpreting the script that I've written linearly, maybe I use x in a specific way that's going to lead to it happening inside of a loop, or when I call a specific function or subprocess to run. And as I was mentioning, object-oriented means that the different data types that I'm dealing with that are considered objects have methods that are going to facilitate our interaction and dealing with that specific type of data. And in addition to that, we can actually create our own objects within Python. And what I mean by that is we can create a class. And so when we create a class, we're specifying here's what this new thing is going to be, here's what it will consist of, here are the things that we can do with it. Okay, so that's a little more of an advanced, concept, creating our own data types. But we do have that capability. It gives us the freedom to do pretty much whatever we want. The language is extensible, meaning we can continue to expand the functionality and the different things we can do with this language. We see here pypi.org. This is the Python repository. We see Python package index. So this is where we would acquire or peruse those modules or libraries that I was talking about, the different collections of code that will enable us to do different programming activities or tasks. And I will show you briefly how we would interact with that. So in my shell, after I've installed Python, you have a few new commands. First, Python 3, right? Or I have mine set to just be Python, and it'll invoke Python 3. So what I've just done is open the Python interpreter inside of my shell, and you could do the same thing in command prompt. I believe on Windows, when you install Python 3, it's called Python. On Mac and Linux, I believe you have to specify Python 3. Now that I'm in the Python shell, I could do something like print hello world. That's cool. And we'll look at how we deal with that shell a little more, maybe a better program than just terminal to deal with that. But what I wanted to show you is we also have this other command, pip, which is our Python package manager, right? Our install and modify tool. So now I could say pip install and the name of some library. Let's try XLSX writer. It might already be installed, but we're going to find out. Look at that. It wasn't. So now what happened when I type pip install and then the name of a package from the pypi repository, first pip is going to check, is that thing already installed? If it is, it'll tell us, sorry, that's already installed. You can go use it. But here we see it wasn't. It downloaded it. It installed it. And now, if I open the Python interpreter again, I can use that library. I can say import XLSX writer. And we don't see anything happen because nothing ran, right? We didn't run any program. What we've done is gained access to the code within this library, inside of this shell. So now I could do something that has to do with an Excel spreadsheet. I can create one. I can write data to it. Does it say XLSX reader? No, so maybe it doesn't have that functionality. Maybe I can't read data from the Excel spreadsheet with this tool. Just create and write data to one. So these are the intricacies that you're going to have to figure out. And how do we do that? The documentation is a very useful way to understand how a thing works. It's essentially the user manual for any given library or function or piece of code. Before we look at the actual documentation, you might have a question like, well, how do I know what library I even need, right? I'm not going to go, if you go to the pypi repository, there's something like, hundreds of thousands of packages. We're not going to look through that. Generally, I would refer you to Google, and we would type something like, I want to SSH with Python. Like even that should get you somewhere. Okay, here you got one explanation, fine. Generally, I like to go to Stack Overflow. This is a community that essentially you can attribute value to people's comments based on their reputation. You see this guy's got 27.3 thousand reputation. That's very high. So this man knows what he's talking about. The community agrees. So we can go look at what other people said. These guys are saying use Paramiko. I agree. So Stack Overflow is one place we can go to figure out what library I want to use. And you'll see that the comments here also include code samples that you can use to try to quickly use this new thing you're learning about or exploring. Once you find a library that you want to use, such as Paramiko, we can then Google Paramiko documentation, Python Paramiko documentation, and then we would see their website, which is going to tell us how to do stuff, right? It says here, starts with this, click that and go do something, right? Here's the code block. Here's an example of how you get started. Great. We'll find that every documentation is different other than the stuff from Python.org. Python.org, right? The website, the group, they have consistency between their documentations, right? So that's nice. And then other libraries produced by other groups, other organizations, their documentation could look completely different, and it could either be better or worse or not comparable, I guess. But that's just something we're going to have to deal with. And again, I find myself going to Stack Overflow in the case when the documentation is unclear or not easy to understand, because I'll end up finding a comment by someone who's worked with that library or this thing I'm trying to do, and they will generally help me understand how to get started and get the ball rolling. So when we say extensible, what we mean is we have access to all these different libraries that will enable us to do some new programming task, okay? And that is updated all the time. So if a new protocol exists all of a sudden, or if there's a new thing that's sweeping, like Docker, right? Docker is really gaining in functionality. Was there a Docker package 10 years ago? Maybe not. Is there one today? Probably. So this is going to continue growing and changing the PyPI repository. Who's using Python? Here are some big names: Google, the NSA, NASA, Netflix. I've personally taught people who work for NASA and Netflix how to use Python. But in addition, a huge sweeping movement, ISPs across the country, Verizon, Comcast, T-Mobile, all these huge telecom companies are starting to incorporate Python into their networking configuration and management, all of it. So who's using Python? A great deal of people, a huge number of organizations. And again, this has to do with its ease of readability and learning and actually making something happen.